burning things. You need to listen more carefully, Zoe.
If you were blowing stuff up, you would be more happy.
Correct.
But
But the last thing we want to do is make Ethan happy.
Yeah, right. As always.
Yep. Well, at least we're all in agreement on it, Ethan. You okay, Zoe?
Yeah.
Good. All right, Zoe, you got 40 seconds left.
I won't have time.
Then you might as well put it away and eat it during advisory.
Yep. Oh, Alex, how are you? Good. I can almost hear you. Nice. Come on, Jennifer, you got 10 seconds. Brienne, oh my gosh. Okay, I'm going to do this one.
I know this one will. Can I get in that bit that I go like this too? I'm talking about, I don't know if that would work. Bit that I like go like that too. I don't know if that would work. Good question. I'm thinking about it, I don't think it would work.
It's late. Whatever. Good morning, ladies and gentlemen. How are we doing today?
Good, you know, I don't think it would work.
What?
For the question video, I didn't think it would work.
You didn't think it would work?
No, because I can describe it, but I didn't know the name of it.
Did the lights just dim on me?
Yeah.
Okay, good. I'm glad they installed these new lights. They work so well, ladies and gentlemen. So, all right. Take out your computers, ladies and gentlemen. Get logged in, and while you are doing so, start thinking about the question of the day. You each are going to have to name an object with either kinetic, potential, or both. You need to name the object and tell me what kind of energy it has. That's where we're starting today, ladies and gentlemen. Then we need to get to our lab today. Dun, 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 dun. Alexa, Kiana, Alex, Anna, Jennifer is not here.
It's actually black coffee. What kind did you get?
They're right up there, sir. All right.
I'm trying to describe you. I don't know the name. These things. I was thinking, but I don't know if they'll work. Because I don't know if they will work. I have a good idea, but I don't think it would work.
Well, Zoe, we'll find out in a second, so relax. All right, ladies and gentlemen, give me your example. Go ahead, Ethan.
Moving train.
What kind of energy?
Kinetic.
Why no potential?
It's not about to fall off anything. Just like on tracks.
Okay, so I'm a moving train across the lowest tracks possible. Okay, good. Excellent. Wonderful. Lucy. Okay, what kind of energy? Okay. Christian.
Throwing the ball.
Okay, what kind of energy?
Kinetic and both.
As long as the ball is in the
Air.
air. Okay, good. Helen.
bottle just sitting on the table.
Okay, what kind of energy? Good, good. Jimena. I'm sorry?
Someone running.
Okay, what kind of energy? Okay, could it be potential as well? Could you describe how, or tell me where they would have to be running to have both kinetic and potential? Not sure? Okay. Person running across a bridge. A person running uphill. Okay. Jaslyn. Car driving, what kind of energy? Kinetic. Go ahead, Zoe. You got
I
one?
don't know if
Zoe, just tell us and we'll talk about it.
it's like, those physics where you flip them over and they run with the liquid run down.
Okay, what kind of energy would it have?
Kinetic, probably.
Actually, it would have both, because if when you turn it over, it would then be going downhill,
And then
correct?
Let it flip over and
Okay,
then we flip
good.
it.
Good, good. Maria
Flying airplane.
would have. Good. Brianna? A car driving on a bridge or under? I just didn't hear what you said. I'm sorry.
On a bridge.
Would have what?
Kinetic.
Would have both. Good. Victoria?
A spring.
Would have what?
Potential energy.
Good. Potential energy. Good. Faith?
My cup has potential energy
Why?
because it could fall on the floor.
Okay, good. Easy.
An airplane taking off.
Okay, now be real specific here. What kind does it have?
It would have both, right? Or both, because it's taking off. So it's starting off in kinetic and it's going up into gravitational potential energy.
Okay, good. Now, I would argue just a little bit with you. Taking off process could mean going down the runway, which it's starting to take off, correct? But if it's on the ground, it hasn't gained what? Hasn't gained potential yet. So now if the plane is actually starting to lift off the ground, now it would have both, okay? So again, good example of trying to be a little bit more specific, but again, people could interpret that a couple different ways. All right, Alex. That's what? Potential. Good, Kiana.
This little cup.
That little cup.
It has potential.
Why?
Because it has the possibility of falling.
Okay, and it's not what?
It's not moving.
Good. Kevin.
A roller coaster.
Okay, now you gotta be a little bit more specific because roller coaster does a lot of things.
Well, when the roller coaster starts going up, when it starts running, it's kinetic energy. But then when it starts going up the hill, it's potential energy.
Okay, good. Christopher?
There's one here.
Okay.
Chemical potential energy.
All right, the Arizona that he drinks has chemical potential energy because it has calories in it. Very good, ladies and gentlemen. Very good, okay? Tomorrow you got a quiz. Those are the kind of things that are going to be on your quiz. It wouldn't surprise me if the first 4 questions on the quiz were describe something that has kinetic energy only, something that has potential energy only, something that has no kinetic and no potential, and something that has kinetic and potential. Would not surprise me at all if those were the first 4 questions on your quiz tomorrow. Questions from you guys? Okay. What I want to do before we get into our lab is I want to look at one more problem off of the worksheet. So if you would, open up the calculating energy worksheet that we gave you the other day. The one that looks like this that we were working on yesterday. And I want you to get to problem number 6, ladies and gentlemen. Now, this is exactly what we are going to start doing today, ladies and gentlemen. A student eats a bag of chips. No, we're not eating a bag of chips. I know, Faith, you're excited. No, we're not eating a bag of chips. And the chips contain enough energy to raise 925 grams of water from 2.2 degrees Celsius to 94.5. In other words, in our lab today, we are going to have an amount of water. We're going to measure it in grams. So here where they have 925, you're going to probably have a number closer to 100 grams. Then we are going to take that water and we are going to heat it by burning food underneath it. Now, this started out at 2.2 degrees. This went to 94.5. Our water is going to start out at about what temperature? Room temperature. So it's going to be around 19 to 20 degrees. Finds the energy released per gram of chip if the bag of chip contains 225 grams. You're going to find the mass of your food. You are then going to burn your food. You are then going to find the mass of your food again. Why? Because unlike when you eat something that you would get the entire amount, when we burn something, there is always some left over. It doesn't completely go away. So we need to know the mass of the food before we burn it, and then we need to know the mass of the food after we burn it so that we can calculate the mass of food that was burned. That is what you are going to be doing in your lab today. So in this problem, again, the formula that we are going to use is right here. This is the same formula you are going to use in your lab. Energy per gram is equal to the mass of water times the change in temp. That's what we were doing yesterday. Divided by 1,000. Why dividing by 1,000? To get from that little C calorie into the big C calorie. But we're adding one other thing. The grams of food burned. To get energy per gram, we have to have the energy divided by the grams of food that we burned. So this problem, ladies and gentlemen, the 925 grams of water goes right here. When we subtract these two numbers, 94.5 minus 2.2, we get 92.3. It goes right here. And then the mass of food that was burned goes on the bottom here. Now, when you do this in your calculator, ladies and gentlemen, if you do not do this correctly, you will get the wrong answer. You have two numbers on the top that you are going to multiply together. So in your calculator, you can multiply those two numbers together, 925 times 92.3. But when you divide by two numbers on the bottom, it is important that after you hit the division sign, you use the parenthesis key. And you want to put both of these terms in one set of parentheses on the bottom so that you divide by the two of them multiplied together. Order of operations in a calculator. We'll do this number times this number divided by this number and then times this number if you do not put these in parentheses. And you will end up with a number that is 1,000,000 times bigger than it should be. Because instead of dividing by 1,000, you will be multiplying by 1,000 and you will be 1,000 times big, 1,000,000 times bigger. So these two numbers on the bottom, you put them into your calculator inside of parentheses when you do this, ladies and gentlemen. And that's the way you are going to get the correct answer. Okay? You have to put them in parentheses. Questions? So when I do that, ladies and gentlemen, oops. I get 0.39 or 379 is the answer that I get. 0.3794. So in this problem, ladies and gentlemen, since it is not done, let's finish it. Energy equals 0.3794. The 4 I do not need to do anything with. This is 3 sig figs. Okay? The 4 I look at because does it round that 9 up to the next number or does it leave it? A 4 would leave it. And the unit is big C cal / G, calories per gram. That is the unit. That is the unit that you will be calculating today in your lab. Questions? Okay. Now, this worksheet is due tomorrow, but I am going to give you time in class to work on this worksheet tomorrow. We're going to do our quiz. and we are going to start the calculations from as much of the lab as we get done today. We will not get the lab done today. Okay? We will do part of the lab today, and then we will finish it on Monday of next week. Okay? So that is the plan. Questions? Okay. So let's open the lab and let's look at the lab, ladies and gentlemen. Go into Google Classroom. Over on the side here, it has the Energy and Food Lab. Please open it up, and let's get to looking at it, ladies and gentlemen. Okay? Let's get to looking at it. All right. Reminded me, thank you. I need to finish taking attendance.
Do Monday.
Perfect. All right. Everybody's here, so that's a good thing. I don't have to worry about doing anything else with the lab. All right. So let's go up to the top of the lab, ladies and gentlemen. We're going to calculate and compare the energy given off by 3 different foods when they burn. Those foods are going to be chips, nuts, and marshmallows. We're then going to compare the experimental value to the known values to evaluate how we did on the lab. In other words, I know from the packaging how many calories there are in the nuts that we're going to burn, how many calories there are in the marshmallows that we are going to burn, and how many calories there are in the chips that we are going to burn. Okay? So I know that, I take it I didn't have this copied into your lab, huh?
No.
Okay, sorry.
Do we get to burn them?
Yeah, you're doing the lab. So
You trust us?
on the box, or in the back, there is a box, ladies and gentlemen, with goggles in it. When you go into the lab, you can grab a pair of goggles. You will need them. You will not be burning things without having goggles on. Number 2, there are lab aprons on the back wall. My suggestion is to wear them because certain foods, chips and nuts especially, when they burn, create a lot of soot, black material, that's going to get on the cans, that you're then going to be touching, that is then going to get on your hands. And if you do one of these where you wipe your hands on your shirt or whatever, you're going to have black all over it. Oh, the best part with this lab is people touch the can, get that soot on their hands, and then they'll be like, man, I need to adjust my goggles here. And they'll leave with black marks up here and down here because I'm not nice enough to tell you you have black marks all over your face. Okay? So please be careful. Okay? Now, you will get good practice at this lab. And the reason why is you are going to do 3 different foods, and you're going to burn each food twice. So literally, you're going to be repeating the procedure 6 times. So it is not a difficult procedure, but it is one that, again, you are going to have to do over and over again. Okay? All right. Does everyone have this? Yes? Okay, then let's look at the procedure. Now again, always in our lab, ladies and gentlemen, we are going to take qualitative observations. And I expect you to take qualitative observations 3 times before you burn the food. So just looking at it. While the food is burning. And finally, after the food has burned. The only ones that are utmost important are these here, because you only get to do these while it is burning. And again, if an odor is given off by all 3, you can put it down for all 3. These do not have to be unique for each food. If it is burning, and they're all going to give off what? Smoke. What else? Steam, heat, light. Those can be things that you write down. Okay? Remember, qualitative is what you feel, what you smell, what you hear, and what you see. We're not tasting anything today. No, you're not eating the food. Great. So, ladies and gentlemen, after that, after you've made your observations, okay, you're going to find the mass of the food sample and the holder setup. This is the food sample and the holder setup. It includes the glass tray, it includes a cork wrapped in aluminum foil, and it includes a paper clip and your food. Now, the paper clip is there to keep the food off of or in the air when it is burning. That way we can put a match underneath it to light it. So that is the reason for the paper clip. And the other reason we use the paper clip is you can adjust it to the size of your food. So when you have the chip, you may want to spread it out more so the chip sits on there better. The marshmallow sits on there better, but when we do the macadamia nut, you may have to make it smaller. Here's the other reason that we do this entire mass. Afterwards, this will be a burned, charred nut, a burned, charred chip, and it may break. And if it does, it's going to land on this glass tray. Now you don't need to bend down and try to pick it up and put it back onto the balance. You take this whole thing over to the balance when you are done and you place it on it. And you do not need to touch the remains of the chips. If your paper clip gets covered in marshmallow and you want a new one, they are sitting in the back of the room at the table in the middle. Okay? Now, we're here. Find the mass of the food sample and holder setup. Find the mass of an aluminum can. At your station, there are aluminum cans that are supported with a nail or a stick on your ring stand. Take this over to your balance and find its mass. Then, ladies and gentlemen, you are going to add 100 milliliters of water. And I need to get these out. I will get these out as soon as we start the lab. I'm sorry, I should have had them out there already. But we need 100 milliliters of water, and it is approximately 100 milliliters of water. So I will put these out there. Now, more important than the volume is the mass. So again, don't worry if you're a little bit over or a little bit under 100 milliliters. But we want about 100 milliliters in there. So you're going to take and you're going to fill this up to about 100 milliliters. I'm a little bit over. I don't care. Okay? I don't care because more important than the volume is the mass. I then put it into the can. And now I'm going to put the can back on the balance. Why? To measure the mass added. And what I will be able to do is take the mass of the can in the water minus the mass of the can and get just the mass of the water, which is what I need for my calculation. Okay? By the way, I'm going to do the same with the food. I want the grams of food burned, correct? So I want this whole mass at the start, and at the end, I'm going to put that back on the balance after it burned, and the mass should have gone how?
Down.
Should have gone down. When we burn it, some of it will be gone. So the mass should go down. Now, I have had groups in the past where the mass went up. That is impossible. That is impossible. But then I find out that they just took this part over to the balance and put this on there. And they did that the first time. And then the second time they did it with the glass dish. Well, the mass went up because there's something there that you didn't measure the first time. Remember at the end of, for those of you who were with me last try, consistency.
Agree.
The tray, the holder, the food, all of it on the balance. The tray, the holder, the food, all of it on the balance at the end. So that way we find how much mass went down. By the way, before you ever use a balance, it better be zeroed.
Agree.
Okay? So, we put 100 milliliters of water in the can and we find the mass of the can in the water. All of these numbers, ladies and gentlemen, are going to go in here. Now, I know this is the one for the marshmallow, but still, mass of the can in the water. Initial temp of the water in the can. We're getting to that. Mass of the food in the holder before burning. All your numbers go in here for each food. When you do it the second time, they go over here. Okay? So, found the mass of the can, found the mass of the can in the water, found the mass of the food in the holder. Find the initial temp of the water in the can. You have a thermometer at your station. Take off the plastic cover.
Mm-hmm.
Turn it on and make sure it is reading in degrees Celsius. Put it into the can. Let it sit there for a minute. You probably are going to be around 19 to 20 some degrees because that water should be room temperature. It's been in the room all day. You write down what the initial temperature of the water in the can is. Okay? Now, we are going to light the food and let it burn until the flame burns out. So, to light the food, ladies and gentlemen, it is really important. A couple of things. Number one, this can be up a little bit higher and out of your way. To light the food, two things. Number one, a match will burn faster toward your fingers like this than like this. So if you hold a match like this under the food, yes, it is going to try to light it, but it is going to move up the match quicker and it is going to burn your hand. Hold the match upright under the food and you're trying to catch a corner of the food on fire. Okay? If you hold it right underneath the center, it will not catch as easily. Especially with the chips, the marshmallows, try to catch an edge on fire. It may take more than one match. Okay? So you're going to light your match. You're going to hold it underneath the corner until you see the food catch on fire. If it does not catch on fire, throw that match in the can, not on your table.
Or the garbage can.
No!
I said, or the garbage can.
Don't throw it in the garbage can. Light another match. And go again. Come on. Move the match away from the food when you try to blow it out. I've seen people blow the match out right by the food and they blow out the food as well. Take your can and now put it so that it is just over the flame. That flame will get bigger. As it burns, it will get bigger. You may have to move your can up a little bit if the flame starts shooting up the sides of your can. Right now, the energy from the food is going where? Into the can, and what is happening in the can?
Can burning it up. Turning it
It's
on.
what? It's warming up the water in the can. It is warming up the water in the can. If you see that the flame is a little bit too high, you can adjust. Make your observations of the food while it is burning. Once you get the macadamia nut burning, it goes well. Okay? Marshmallows will sometimes burn out. Chips will sometimes burn out. That macadamia nut will burn for about 5 minutes. Okay?
The marshmallow
Now.
will get blacker.
I'm letting this go. As long as I'm getting a change in temperature in the water, if that macadamia nut were to stop burning right now, and I have a change in the temperature of 3 or 4 degrees, I'm good. I'm good enough. Why? because it's energy per gram of food burned. I'm not burning as much food. I'm not getting as much energy out, but it should be the same as if I burn for a longer time because I would burn more food but get more energy. Okay? When your food does burn out, and I'm going to stop this because I don't want to take up too much of your time. When it burns out, this is the important thing. You need to make sure you are stirring this water in here to distribute the heat. Now, this temperature may continue to go up for a few moments. Okay? Keep stirring it. Keep watching the temperature. When the temperature finally starts to drop, we want to record the highest temperature reached. Remember we did that in an earlier lab?
Yes.
The specific heat, same idea here. We want to get the highest temperature reached. So you got to keep stirring it and watching the temp. If you're stirring it and the temp starts to go down, you've reached the highest temp. If the temp goes down and you're not stirring it, stir it again and see if it goes back up. If it doesn't, you've reached the highest temp.
And that's the number that you want.
And that's the number that you write down for the final temp in the can.
And it stops, right?
There is one more thing that you need to do. Okay? You are going to take the thermometer out. Now, you see the black stuff on the side of the cans? That's the stuff I'm talking about that you're going to leave with on your forehead and your face if you touch. So I'm going to touch it here. The can will not be that hot. I'm going to take this water over to the sink, and I'm going to dump it out. I'm also going to take and get some of that black soot off of the can so that I don't get it on my hands later on in the experiment.
Mm-hmm.
You can take a towel. You can wipe it off. Be careful. The bottom is where it really gets out. So take and wipe that bottom off. The other thing this will do by wiping this off, ladies and gentlemen, is when you use this can and you go put it on the balance again, your balance won't get dirty. Okay? I do need to do one more thing. Take all of this over to my balance and put it on there. Find the final mass. Now, my final mass here might have gone up. Anyone know why? That first match, when I blew it out, the head of the match ended up, I thought it ended up on here. Did I?
Yeah.
Okay. So if something like that happens and part of your match ends up on here, you got to get it off of here otherwise, because that wasn't in the mass originally. But now I just take this, I put it on my balance, find the total mass. I will have a glass jar in the middle back there. Take your food over to the glass jar, dump your food off of this into the glass jar. Do not throw it in the garbage can. Why?
Because it could, with the papers on.
With the papers and things that are in the garbage can, it still could catch them on fire. We don't need a fire in class today.
No.
Okay?
I don't want to go on
If
fire.
your paper clip is destroyed, take and throw it in the container with the food. Grab a new one and go ahead and get your second trial going. Your second trial, you got to do everything over again. New food, new mass, new amount of water. Can would be the same, but find the mass again, just in case. Go.
Could we do like the qualitative and the
Hang on. I meant go asking a question. Hold on a second.
observation, or like the qualitative and quantitative questions first, like for each one?
Here's the thing. If I would do this one food at a time,
Okay.
because they're going in 3 different sections of the lab. This is all about the marshmallow. The next page is all about the macadamia nut. And the last page is all about the chip. You're going to have time to get it all done. And by the way, you don't need to take observations the second time you burn the food. You don't need another set of qualitative observations when you're doing it, when you do the second macadamia nut. All you need to do is collect your data the second time.
Unless if you forget.
Well, you shouldn't forget because you should have written it down.
Right.
Okay?
Oh, so we're doing it twice. Okay. For
You're doing the same thing. After I do one macadamia nut, I'm going to do a second so that I can average them together at the end.
and
we'll
see
show
if
you how to do
anything
that.
changed.
What?
And see if anything changed.
Correct. I don't expect to get exactly the same numbers, but they should be close.
Okay.
Okay? But the nuts will not be the exact same mass. You may not have the exact same mass of water, things like that. Okay. Goggles there, aprons there. There are 18 of you. That's 9 groups of 2. There are 10 stations set up, so there should be 1 that is not used. Go to work. The food is in the middle. I don't care if you start with the marshmallows or the macadamia nuts. The choice is yours, ladies and gentlemen. I will get you your graduated cylinders out, and I will also put out the container for the waste. Someone will be available because there are exactly 18 of you. The chips I don't have out. The chips will do the next time. So you can either begin with marshmallows or macadamia nuts. By the way, I have hair ties. I will put them out up front. If you want a hair tie to tie your hair up so that you don't accidentally get it into burning food. The hair ties are up here, ladies and gentlemen. If you need one, please feel free to come up and grab one.
Assuming you're up there, but
Yep. Okay.
I could not reach that.
Good. That's why I put things up high to keep them away from the kids.
Is that team sport?
Make sure your balances are on. Make sure they're zero. If your can, the tab on it breaks off, I have a box full of cans up here. Take the can that is broken and put it here. Grab a new one from here if you need it. You all have ones that are good, but please be careful. These stupid Mountain Dew cans, 0 sugar. They don't have a hole in the top of the tap. You can't use these, so you have to take a different kind. The regular Mountain Dew, the other ones that are in here, they will work fine. Alright. Container for garbage. Here's the container for your burned food in the end.
Yeah, I know. You have school too. So.
Okay, goggles, Alex. Goggles, 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 Keanu. Goggles, goggles, goggles. Remember to find the mass of the can before you begin. If you turn your thermometer on and it doesn't work, let me know. I will get new batteries for it. And please make sure you're reading in degrees Celsius. They are clear goggles.
It's blurry.
Maybe that's just your vision.
No, it's not my vision. Yeah.
Get your other stuff going. Get your masses and things. Yes, you have to do it all together because after it's burned, you're going to put the whole thing back on there. Now, it isn't so important that the marshmallow is sitting on the thing. You can just set it on the side, but at the end, you just want to pick that up and bring it over.
It just seems like accurate.
Did you bring a zero?
One. 9, 2, 4. So 113.92. Mr. Brand,
Yes.
is this calculation correct?
Is this calculation correct? What calculation are you doing? Did you put it on there and is it zeroed when you started?
Yes.
Then it should be correct. How many grams is it?
A lot.
What is a lot thing? Give me a number. 11 grams is not a lot for a kid. What?
100.
With the water in it? Yeah, that's what it should be. Yeah, with the water in it, yes, because water is about 100 grams.
It says yeah, you're gonna do it before you burn it and then after you
Here you go, Alex. Alex, put in your dang goggles.
I think it's the
And then that's lower, so
yeah, 6,
6,
8, 6.638.
you can just do it. Wait, where's your age?
What's wrong with it? You're reading the temperature.
You can do as many batches as you need.
So we are just
There's a cup like that at your station.
Oh, okay.
There is a metal container at your station for your matches, ladies and gentlemen. It's probably over by where the Bunsen, where the gas comes out. As long as it doesn't fall off, as long as it stays on there, you will be fine. Now, if it stops burning, stir your water and see how much of a temperature change you got. Whatever way it'll burn. Correct.
I know it. So we just start it and then put it over it. Okay, initial temperature will be okay.
I find that so weird. Like a creative. So many people do that.
Okay, so
Yeah, it's not fair.
I said bubbly.